Good morning. I'm Tim Mackin with the Master Builders Association, and welcome to the grand finale of our three-part series on embodied carbon. Today, we culminate in EC 301, the event that will empower you with the knowledge and strategies to make a lasting impression on reducing embodied carbon emissions. It is my pleasure to introduce our esteemed guest presenter, Kayla Reddington from Turner Construction Company. With her wealth of knowledge and expertise, she is the guiding light for our series finale. Throughout Kayla's presentation, feel free to utilize the chat feature in your Teams meeting platform to post any questions or thoughts you may have. We'll address them at the end of her presentation. Without further ado, let's dive deeper into the final chapter of how to implement embodied carbon transparency and reductions in your projects, a crucial piece in this three-part puzzle. Kayla, take it away.
Thanks, Tim. Like Tim said, today the focus is going to be how to implement embodied carbon, transparency, and reductions on your projects. So this is really kind of taking everything to the next level, but still at a high level overview of what our capabilities are. I've already been introduced. So the first really key concept is to start early. I like this graphic that was developed by the World Green Building Council, which shows the impact or the carbon reduction potential by starting early is so much higher in that planning and design phase than it is in the construction, operation, and maintenance phase. And I know as a general contractor, unfortunately, we're not always involved early, but this helps support a theme that has always been in the green building world of that collaborative theme, that IPD theme, getting the GCs and every partner engaged as early as possible to really be able to have that collaboration and optimize the design. So here's just a quick graphic of some embodied carbon strategies that we're going to talk about today. And the graphic is showing the impact versus the difficulty to implement. And really showing that, you know, there's some things that have a really high impact but are difficult to implement, and then some items that might have a lower impact but are easier to implement. And so you'll see this graphic on some of the other, we're not going to go over them all now because we're going to kind of go over through them throughout this presentation. But you'll see it on the bottom left-hand side of the screen with the item highlighted in orange, so we can see kind of where it is on this scale. The other tool we're going to utilize is this tool that was put together by the U.S. Department of Energy, Better Buildings. It's called their Embodied Carbon Resource Navigator. It's an interactive tool that you guys should definitely check out online. But we're going to kind of go through it in slide format a little bit to help frame our capabilities of implementation on our projects. So this is what I'm referencing as part of that tool, right? This content here with the blue and the green is part of that tool. So again, this is interactive. If you do it online, we're kind of fake the interaction here a little bit. So the first question is, I have a project. Is my client interested in reducing their carbon footprint? And so ultimately you can select yes or no, and a pop-up will come up. So in this case, if we said no, you can see on the right-hand side here, what they provide is an overview of embodied carbon, kind of all the things that we've been talking about in the EC 101 and the 201 and the why, right? And from a impact perspective, kind of going back to that graphic that I showed on the last slide, educating the project team, there's a really great opportunity here. You know, you're not going to achieve the highest reductions on the face of the earth just by doing the education, but it's still an opportunity to make progress and the very first step. The second part in their interactive resource here is my client interested in low embodied carbon options? And this is another kind of educational resource going a little deeper, embodied carbon versus operational carbon, how the time is now, how it ties into ESG goals, and some things that you can discuss with the clients or designers. And so again, this is along those educating the project team scenarios, and some opportunities here and the items that we've discussed previously. Next, we're kind of really getting into the meat of it, right? How do we implement some of these things? And so the question they asked in this resource is, am I capable of specifying low embodied carbon options? And if you're not capable, clicking no, would like to learn more. This is a really great overview of some low embodied carbon options and strategies, as well as low embodied carbon solutions, both from a material perspective and a methods of solutions perspective. So we're going to kind of dig into some of these solutions a little bit further in the next slides. The first thing that you saw on that list was build less, reuse more by extending the life of existing buildings and materials. This is a really optimal strategy for reducing your embodied carbon on projects, and something that, once again, going back to starting or doing it at the start of design. I mean, this is the very first decision to be made on a project, and something that should definitely be analyzed and ultimately should also be taken credit for as it relates to embodied carbon reductions. There's a lot of focus on the materials, which we'll get into as well, but there's a really much higher opportunity to reduce by just reusing existing materials that have already been fabricated. So there's two tools that we want to highlight, and there's a plethora of tools in the market as it relates to embodied carbon. To be honest, it's a bit overwhelming. So, there are things beyond this, but just a couple tools to kind of show you high level what the opportunities are and how easy it is and how you don't have to be a designer in order to just quickly analyze some of these things during the pre-construction or design process. So the first one is the CARE tool. And I'm just going to pull up here. The interaction of it, because it'll be better than the screenshot here. You can see my web browser, right, Tim? Okay, thanks. So again, this is the CARE tool. It stands for Carbon Avoided Retrofit Estimator, and it does exactly what I was describing and kind of compares doing nothing to a building, reusing or doing an addition, or doing a brand new out-of-ground building. And I'm not going to go through every single detail, but I just wanted to show you the level of detail is definitely very high level. It's meant to be interactive so that you can toggle between. So you start with general information. There's default settings for climate information, for electricity and grid emissions, but then you can also adjust as well. Then from an existing building perspective, you put in the square footage, again, type of structure and some default settings for floor to wall ratio or window to wall ratio, which can be adjusted as well. And EUI information, which defaults but can also be adjusted. And then you analyze, what are you able to reuse of the building, or what do you want to analyze in terms of building reuse? Does the reuse include an addition? Will there be a change of use in the existing reused building? What's the target reduction in energy use? Assuming that you're updating mechanical systems, there's definitely an opportunity with new technology from an energy use perspective, renewables, percentage of structural system reuse, of envelope reuse, right? So there's definitely a little bit detail here, but it's really high level and very easy to toggle between so that you can see what that toggle does to your graphs. And then the last component is new building. So putting in similar metrics as it relates to building a new building out of ground, so that ultimately you can compare and develop this graph that we were looking at earlier of the carbon emission impact from doing nothing versus reusing or doing an addition. I did not do an addition in this little example here, or doing a new building. And you can see from an embodied carbon perspective, the embodied emissions associated with building new are much higher than reusing and an addition. And on the slides that we were looking at before and the little example that I threw together, you're seeing nearly a 70% embodied carbon reduction for building reuse in lieu of a new building, specifically in the embodied carbon emissions, which you're not going to see just from the technologies we currently have available for concrete reduction and steel reduction. So the next tool is the EPIC tool. It's very similar in the sense of those early decision makings and opportunities to toggle through. In this case, you put together a base case. Again, some super simple metrics: composite steel frame, what type of project, square footage, planted area, etc. And so that defines your base case for the project. And then your base case can have opportunities to reduce emissions, such as same thing, structure reuse, cladding reuse, etc. And then you have the opportunity to develop additional scenarios so that you can compare. So in this case, I have the base case here, scenario 1 here, in which I was able to kind of toggle a few different decisions, and then scenario 2, in which I was able to toggle different decisions. I can toggle this comparison on, and then it gives a comparison chart of your base case and the embodied emissions. Apologize, the pink being the embodied emissions and the blue being operational emissions, and comparing them among the 3 scenarios that were identified. So 2 really kind of simple tools to whether share with design teams or share with clients as you're in that pre-construction process for early decision making, and then ultimately as the GC help to kind of estimate those scenarios. You kind of know the inputs that we're putting in at a really high level. How do we provide the cost impacts to that as well? The next topic to discuss is transparency documentation. So this is another really good way to implement improvements on your project as it relates to embodied carbon. We're kind of showing 2 scenarios here. The first one is just requesting transparency documentations, and the second is actually requiring transparency documentations. And when we talk about transparency documentation in the embodied carbon world, it's environmental product declarations, or EPDs. So from a request perspective, requesting EPDs is, again, nothing new. They're requested very often for lead projects to hit points. There's nothing wrong with having the request, and really the purpose of it is to let manufacturers or suppliers know that there's an interest in this in the market. So if they weren't sure what an EPD was, or they were on the fence about developing one for their specific products, this helps them know that there's an interest in the market. If 90% of the projects that they're pursuing are asking for EPDs, they understand where the market's headed. And the way to take that a step further beyond just requesting it and kind of having it in the specifications is requesting, what's highlighted in red here, is if an EPD is not available, provide a dated written confirmation on manufacturer's letterhead that an EPD or an LCA is not available. That just kind of takes it the step further to have the manufacturer or supplier recognize the fact that they're not there yet, and make sure that they're basically reading what has been specified. Taking that a step further, which is obviously much more difficult to implement, but would make a much greater impact, would be requiring transparency documentation. So we've seen things such as general contractor shall submit environmental product declarations, which document the embodied carbon of materials, cover a minimum of 90% of materials, for example. You know, you got to be careful to choose materials that readily have EPDs available, and then also know your market, right? It's the Pittsburgh market, for example, as it relates to concrete or ready mix EPDs, not everyone has them. So requiring this, you have to know the impact that this would make on the project, but we do want to get to a point in the future where we can require EPDs and it doesn't have any type of hindrance or impact on competition on the project. So that's kind of taking the transparency documentation to the next level. taking that an even step further, so requiring the EPDs, all the EPDs do are provide transparency. They provide what are the emissions associated with that material, but it doesn't require any specific reduction in the emissions associated with that material. So again, taking it a step further to a more difficult to implement level, but having a greater impact is requiring optimization for specific materials. So I'm highlighting just a couple materials here, some of the most prominent in the industry that everyone's focused on right now. First being concrete. So requiring a specific amount of cement content replacement, or requiring a specific amount of reduction from a baseline in embodied carbon are some of the strategies that can be utilized on projects to require that optimization for specific materials, specifically being concrete. The next example here is steel. So similarly in steel, you can require a certain amount of recycled content. You can require using EAF technology for the fabrication of the steel in lieu of BOF, or a basic oxygen furnace. And so this is where you can really drive those reduction opportunities and optimize the materials on the projects. And then the last one is wood. This is a little flipped on the head in the sense that it's a biogenic material. It would replace that steel or concrete, and ultimately be an opportunity to reduce embodied carbon on the project once again. And so this would be a requirement for an optimization in specific material example as well. The next thing that I wanted to show was the embodied carbon in construction, or in construction calculator tool, or EC3, where on there's an opportunity to find and compare materials as well, sticking with that requirement for optimization of specific materials. I'm going to pull up my web browser again. So this is EC3. It's a free software program that anyone can just create an account and sign into. If I go to the home page, you'll see on the left-hand side here, there's kind of two main opportunities on here. The first is find and compare materials, and the second is plan and compare buildings. So we're going to show both today, but right now we're focused on find and compare materials. I'm going to use a simple material. I'm going to go to finishes. I'm going to do it via the tree map finishes, and then flooring finishes, and then go to carpet tile. So within here, you can put in a lot of details as it relates to the carpet, but I'm going to keep it really broad and just go to carpet tile. And then search all the carpet tiles that are in the database. So basically what this is it's a database of EPDs. It's not an exhaustive database. It's anybody can add EPDs to the system. So it's hopefully as many that are out there on the market when it comes to something like a finish, like floor tile, but you know, it may not be exhaustive. So in the search for specifically just carpet tiles, we're seeing that there's 557 EPDs currently in the EC3 program. As we mentioned before, there's opportunities to compare. You can compare by manufacturer, and then you can compare by materials as well. And just to share what this graph is showing you. Yeah, here we go. This gives the best description. So basically it's a box and whisker graph or chart, right? So this purple line represents the Carbon Leadership Forum baseline. You can see on our example here, it's the 2021 Carbon Leadership Forum baseline, which was developed. The green portion represents that 80% of the EPDs kind of fall in this green portion. And then this top line is the max and this other one's the minimum. So those are in a way kind of the outliers, right? And these are where the averages fall. So when you look at something like comparing the manufacturers, you can see very easily on this chart where the lowest is, right? Interface has carpet tile that's actually negative on the embodied carbon kilograms of CO2 equivalent. And this kind of compares all the EPDs that are compiled in the system from a manufacturer perspective. The other thing you can do is compare products themselves. So I'm going to pick 4 random products here. And so you're able to see the global warming potential in kilograms of CO2 equivalent per foot squared, which is an output of the EPDs, compared across these 4 different products so that you can ultimately help drive decisions on the job. And then you can also see that the 4 that I happen to select are much lower than the Carbon Leadership Forum baseline, which provides a reduction and an optimization on the project. So just quickly checking some of these things for the specifications is helpful, and that's what the EC3 tool can help with. Okay, so going back to the embodied carbon resource by the U.S. Department of Energy, we said, how do you specify embodied carbon options on the project, and kind of learned a little bit more about that. The next question they have is, am I satisfied with my client interactions regarding low embodied carbon? No, I'd like to provide additional options. So one of these additional options highlighted here is doing a life cycle assessment. There's many programs you can do life cycle assessments in. It's definitely more of a design tool. I wouldn't say that this is something that we would do often as general contractors, but being aware that the LCA exists on the project is important. So life cycle assessments, again, they're part of LEED as well. You can get a point associated with just doing a life cycle assessment, and then you can get additional points by reducing your carbon impact based on that LCA. So kind of modeling the impact. When you see those reductions trying to be met on projects, you'll see the implementation of the recycled content of the steel, of the concrete reduction, or the cement reduction in concrete, for example. So ultimately, we as contractors need to know that these LCAs are being developed, that there's reductions being targeted, so that we can support that through our procurement efforts of the materials, right? Making sure that we're meeting the specification requirements to support this LCA analysis. Some of the challenges with LCAs are just the data that's in them. It's kind of, again, at a it's only as good as the data that's in the LCA, and so sometimes it's more at the design analysis level as opposed to a product specific level, which kind of gets into our next category here. So in that no category, on the resource tool, there's another button saying I'd like to learn how to calculate embodied carbon of a building. So within this resource, again, if you go online and look at it, there's a lot of hyperlinks and a lot of resources here. And in terms of calculating your embodied carbon on the project, I really like this graphic they have here of the analysis coverage over design and construction phases. So you can see this LCA and tools like Tally, OneClick, Athena, they're really used in that design process, and they're modeling the life cycle assessment, where EC3, which I was sharing before, really focuses on procurement information and the specific materials that have been procured and been implemented on the project, and not necessarily aggregating high-level data. So this is definitely where the contractor comes into play, of making sure to hopefully support what's in the design, but ultimately calculate our embodied carbon on our projects. And so I'm going to pull up EC3 again. I had shared that on the left-hand side, there's kind of 2 tools. The first is find and compare materials. The second is plan and compare buildings. And so this is where you can essentially develop an embodied carbon estimate for your project. So I used a template that was already in there. So that's why it's in Seattle, because it was just already developed for me. You can develop templates for your company, for your client, whatever you see fit. There's definitely some high level information that you start with, and then you get into an estimate that looks very similar to a cost estimate. You can switch it from uniformat to master format. It's not showing up there, but there's an opportunity to flip from uniformat to master format, so whatever you're comfortable with. Again, I'm just going to show one really quick example of inputting data. I'm going to go with the interiors just because it's a little easier. And input carpet or ceiling tile here. So I'll do ceiling tile. So say we have 150,000 square feet of ceiling tile on the project, of one specific type of ceiling tile on the project. You can see, again, it looks like an estimate: cold form metal framing, gyp wallboard, insulation, ceiling tile. In 150,000 square feet, the big difference is linking. Instead of linking a unit cost here, you're going to link an EPD. So again, the whole purpose of this EC3 database is that it has a bunch of EPDs in here. So I'm going to just search all the ceiling tile EPDs that are in the system. 732 ceiling tiles came up within the system. I think I previously selected this one. I'm going to select a random ceiling tile to be utilized. And now that ceiling tile EPD, we click on selective. I apologize for all the pop-ups, but that ceiling tile EPD is now linked to my estimated square footage. And so it's pulling in the GWP associated per 1 square foot of this type of ceiling tile, multiplying it by 150,000 square feet, and providing what the overall global warming potential impact is of that ceiling tile specifically. So in this case, 75,000 kilograms of CO2 equivalent. So once you do that for all the materials that are on the job, you're able to develop an estimate of your embodied carbon on the project. So they show those estimates in many formats: report format. I think it's going to end up downloading something, but the purpose is it'll show it in a estimate type of format on an Excel sheet. There's also an opportunity to look at a Sankey diagram. This is something that EC3 utilizes to understand where the opportunity is for reducing your embodied carbon on the project. So once again, when more materials are added in here, you can see that there is a conservative embodied carbon estimate showing an achievable embodied carbon target based on the data in the system, that there's an opportunity for a 70% reduction. Typically you won't see as high of 70% once you put more materials in here, but this just has kind of those ceiling and carpet tiles in here right now. Okay, so there's in both cases, there's videos on here that you guys can take a look at to kind of walk through those EC3 scenarios in more detail, but just wanted to give you a high-level overview of opportunities to implement both transparency at a really high level, right? Or the education was the really high level. Then we kind of got down to transparency, then looked at those high-level decisions. How do we reduce embodied carbon as early as possible on our projects? And then how do we actually calculate embodied carbon on our projects? And ultimately, those calculations help lead to decisions to reduce embodied carbon on our projects. Thank you.
Thank you, Kayla. I'll open it up to some questions. We do have 2 comments in the chat. Brian said, when it comes to cement replacement, the specifier needs to know the impacts of those choices, and we're not really sure how many do, and how we, I guess maybe Brian's looking at how we encourage those specifiers to start to look into this. I think you've introduced a lot of great tools that can be shared and utilized to make the case to certainly look at a more or something that impacts with less embodied carbon. And then John Cooper, our presenter from Nucor and EC 201, said, great presentation. Thank you. I hope you were able to share this information, John. We will be sharing all the information from the virtual session EC 101, as well as this 301, and then we will have a link to all of the slide decks from the 201 presenters as well. Does anybody else have any other questions they would like to ask? Because you're only going to get Kayla for so long, and then we'll have to coax her to come back here and present for us at another time. But I wanted to make sure that if there are any other questions, you can ask them at this time. If not, I think that, Kayla, do you have anything else to add?
No, I'm thinking about this question when it comes to cement replacement. The specifier needs to know the impacts of those choices. The specifier needs to know the impacts of those choices. Are you saying in terms of the impact on the project? And I kind of agree with you. I think that's the purpose of us understanding the market conditions and understanding what that impact is, right? Like, are we capable of making those cement replacements, or will it require a longer cure time, or does it work from a winter weather perspective and pouring the concrete in the winter? And so that's why that integration of the contractor understanding these embodied carbon reduction strategies is important, to have those collaborative conversations as early as possible and make sure that we're vetting out all of those impacts that you're referencing, Brian.
Okay. Well, there doesn't seem to be many more questions in the chat, Kayla. So I want to thank you today for presenting. This has been fantastic. I can't thank you enough. Also, I'd like to give a big thank you to the Green Builders Committee. Without your hard work and dedication, this series would not have been possible. Kayla's been a huge part of this throughout our journey on these 3 sessions. She's been very impactful and our subject matter expert on a lot of these different topics. The Green Builders Committee will continue to lead the way, keeping the MBA membership informed about embodied carbon in construction. We will continue to have sessions like this, educational for our membership as well as others. We will continue to spread the word, and we look forward to seeing you at our next event with the Green Builders Committee. Thank you, everyone. Thanks, Kayla.
Thanks, Tim. Thanks, everyone. Have a good one.